yeah, it was interesting. It was interesting. It was interesting. A bit challenging because obviously when you're working with a group of at least 6 to 10 people, and these are people who are experts in their fields and they believe what they say goes or what. It was a bit challenging. I won't lie to you. It was challenging. But then I think I developed more of like the softer skills, the communication, all of that.
Now I want us to move on to career paths. So, Rufaro, please tell us some of the career paths that chemical engineers have. Because if I'm being honest, when I heard chemical engineer, I was just seeing somebody in a laboratory with test tubes and chemicals and tests, I thought of chemistry. So just tell us some of the career paths that somebody has. No, it's true. Because it's true. I'm not lying. And if you look at this other side of if civil engineering, I have to tell you, when you thought of civil engineering, originally you thought of buildings and roads, and that's where it stopped. And there is so much into it. So we don't want to just think of chemical engineering and think of a laboratory and chemicals and a test tubes. So please let us know some of the career paths that that one would have should they want to venture into this field.
Okay. Where do I even start? We can start off with the obvious, the process engineer. So they basically it's basically everything that I've discussed before with being a process engineer with regards to equipment and all of that. But you can also go into quality control. Those skills that first year of chemistry, I don't know how it is on other universities, you can also use those skills into quality control. So basically after the product has been produced, you now have to test and make sure that it complies with whatever the health or whatever guidelines there are that exist. You can be a safety engineer and basically just monitoring processes and making sure that temperature is controlled or pressure is controlled or all of that. You can be an environmental engineer, sustainability and environmental. So basically assessing how whatever process it is that you are involved in, are the emissions according to the guidelines? Are we polluting water? Are we polluting the air? You need to make sure that the company isn't doing that. And that's a role that a chemical engineer can take on. You can go into so these beginning ones, they can go into any type of industry, because as long as a product is being produced, there are some guidelines that need to be adhered to, and a chemical engineer can come in through that. So that whether it's like maybe it's a paint company, you're making paint, or it's food and beverages, or it's pharmaceuticals, or it's energy, so oil and gas, petrochemicals. So you can also use those career paths do exist in various industries. Another role is the consulting that I was telling you about. You can go into consulting. Academia, I don't know why people don't like talking about academia. Academia is actually a really good part to take.
Exactly.
Academia, research and development. Yeah. So there are different roles. It's just that sometimes you don't know whether you as a because you'll come and you say, oh, I'm a chemical engineer, but then the job description or the title doesn't say chemical engineer. So then you think, oh, I don't actually qualify. But then when you read the description, this is for people who are job hunting. If you read the description, you actually see that, oh, actually, as a safety, I can be a safety engineer because I know about health, safety, and the environment. I know this and this and this. I can do that. I can prepare this. Or you'll find that the skills that you've had from chemical engineering can apply to different roles, quite a lot of roles. Yeah. Yes. But I can also
Okay.
touch into, I don't know if you'd want me to do this now, but like just the different branches, like the different actual fields where you can, where you'd be
Mm-hmm.
appreciated as a chemical engineer. I just briefly touched on
Yes,
them, but then
yes,
I don't know if you'd like me to go into more detail, like different companies as
yes,
well, or
exactly.
oh, okay, sure.
Yes.
Okay. So what I was thinking, the oil and gas, so petrochemical, so making your fuels, chemical engineers are needed there. So I know, I'm only saying I know of these things because unfortunately some of these bursaries are only applicable to citizens. So for me, unfortunately, but like Sasol and BP, Shell, Chevron, those are all companies that work with fuel. And you may
Mm-hmm.
think you wouldn't actually realize that you don't just all of a sudden get fuel. You need to first extract it from the ground, from natural oil or crude oil,
Yeah.
and then you need to separate it out into your what is fuel? What's fuel? Diesel, sorry, diesel, petrol. These are all different types of chemical compounds that need to be, sorry, I'm zoned out. What is fuel? That need to be separated out into whatever it is that the desired products are. So it doesn't just start as you just get fuel. It needs to be purified. It needs to, and all of that a chemical engineer can do. So yeah, Sasol,
Mm-hmm.
Shell, even Total Energies, as long as it's um fuel industry, fuel company, then a chemical engineer can definitely be there. Yeah, pharmaceuticals and biotech, which is where I am. I think I've described the R&D side, the research and development aspect of it, but then you can also be, because remember, chemical engineering from raw material to a final product. So with pharmaceuticals, the flow sheet that we showed recently, just a few seconds ago,
Yeah.
basically a chemical engineer can be there, whether it's actual optimization of the process flow sheet, yes, something like that. That's pharmaceuticals, that's in biotech. Whether it's that, whether it's also what I was saying, quality control, making sure that the vaccine that you've produced is actually safe, is actually safe. There you'd work with people more in the medicine in the medicine field. So those that do clinical trials and all of that, that's where you'd work hand in hand with them. Just to make sure the safety of whatever product you have. So that's vaccines, that's any pharmaceutical therapeutics, so even Panado, paracetamol, anything, a chemical engineer can be part of
Mm-hmm.
whatever that team looks like, whatever the working team looks like, the workforce, the chemical engineer can be there. Some of the pharmaceutical companies are there's the one that I worked with, Afrigen. There's also this one called Biovac. They mainly do vaccines. And then there's also Guess Labs, which is
Okay.
it's a company that works with, it's more of a niche because they're working in with this cannabis infused therapeutics. So that's also another company it's still quite niche in Africa anyway. And then globally, you
Mm-hmm.
have your Pfizer, you have Thermo Fisher Scientific, you have,
Yeah.
so there are different companies where I think if another thing, sorry to digress, but like having the skills is one thing, but another thing is knowing how to network. And yeah, that's
Mm-hmm.
a difficult one, knowing how to network.
That's a good one.
Because yeah, networking is something that they don't teach. They don't teach you how to network
Ah,
because
got it.
you may be skilled.
Yeah.
You may have all the skill, undergrad, whatever the degrees are glowing, you have them. But it only just takes one person to give you a shot. But nowadays, yeah, you need to
Uh-huh.
network. And yeah, so that's something that I'm bringing that because I'm actually currently struggling with that. I was telling you earlier how I get ghosted on LinkedIn from like maybe
Yes.
recruiters or hiring people. Yo, it's difficult. It's difficult.
Yes, it's very difficult. Networking, it comes naturally to some people. The people who communication come naturally to. But then there's some of us who we have to be very intentional and learn the skill, how to communicate, how to network. Yeah.
Sorry to digress a bit. Do you have any tips for how to network? Just a very quick tidbit. No,
Now that's a good
serious,
idea because I'm
serious.
gonna write it. I'm gonna write it down, Rufaro, and we're gonna do this. We're gonna do content on this one because
Oh
I
my
don't think it's just
gosh.
us. I have to be honest. I don't think it's
Yeah.
just us. But then
Okay.
personally, what I've done before we get to like the deep stuff and what
Yeah.
experts recommend, what I've done is to there are events that I go to. Like sometimes there are this you do have the association, the engineering associations in South Africa, right? So if you
Mm.
join those ones, and then sometimes they would have these events, and you go to those kinds of events. I've had, I mean, two different kind of scenarios. There's sometimes I go and I feel so intimidated. And then sometimes I go and I'm just okay. And I realize the difference is if you just open up to somebody and just start having a conversation, it's gonna be very difficult at the start, but then it's going to ease in and then it's gonna be very easy. But then if you don't and you just give in to that intimidation, then it's just gonna you're just gonna have a bad if you're having an evening, it's just gonna be a terrible evening. So when I was, I have to say, I was mentioning that some of these things you have to actually be intentional. And for me, what I did, especially with public speaking, is I went for training. So when I was being trained on public speaking,
Mm.
now what I was told is that you see the way sometimes you look at somebody, you're like, this person, I don't think like they're even afraid of anybody. I mean, they can just go and talk to a million people and they are not even shaking. So what I was being told is, you see now the butterflies, they never really go away, even for the people who look like
Mm.
they're great speakers. So they if with practice you learn to ignore the butterflies and the fear and the intimidation. So when you ignore it and do it, the more you do it, the more you get the confidence to do it and you get better at it. So then it's like you're silencing the butterflies, but they will ever be there, even for great communicators. And for me, that changed it for me. And she was telling us
Wow.
that um yeah, she was telling us if you want to swim and you don't get into the water, you'll never learn how to swim. So just do it no matter how, even if you're doing it, you're talking to somebody and literally you feel your voice is shaking. You just go ahead and do it.
Yes.
Oh my
Yes.
god. That's what I do. Yeah.
Thank you. Thank you so much for sharing that. Yeah. Yeah.
Yeah.
Very encouraging. Thank you. No, really, thank you for sharing that. That's very encouraging. Yeah.
I was wondering if you had finished your thought on where to work and the career paths.
Oh,
Had we gone through all of them?
just one more. One more. Food and beverages.
All right.
Food and beverages. You can
Mm-hmm.
also work there. So certain companies that I know of that also have bursaries and stuff is Unilever, Coca-Cola, Pepsi, Nestle, all of those
Mm-hmm.
companies, sorry, they also hire chemical engineers, process engineers, to
Mm-hmm.
also help
Mm-hmm.
with quality control and also just safety and all of that. So it's not just restricted to anything small, actually. You can work in different companies. These are just a few that I've mentioned, as well as consulting. I had mentioned earlier, but like consulting is also a career that you can pursue with. There's McKinsey, there's BCG, there's so as long as a consulting firm. I'm just naming the big ones, but then any kind of consulting firm,
Yeah.
and you can also work in water treatment plants as well. There's just really a
Mm-hmm.
lot of places where you can find chemical engineers being
Yeah.
appreciated.
Okay.
Yeah. So yeah, besides that, and the banks as well. You can also work in maybe data analytics in banks. That was basically an overview of some of maybe the main fields where chemical engineers end up working. And to actually, what surprised me a lot is how most of the people that I've learned with, only a few of them are actually doing something that's
Yeah.
chemical engineering related. Most of them are in consulting and banking, which is actually quite interesting. Like, I
Okay.
don't know why, but that's just something that I've
Yeah.
noticed, which is also why I'm maybe. I also want to pursue that and see what it's like being more corporate, being in the corporate spaces and consulting, which is why I'm trying to Python. We must learn Python, how to code, as well as other
Okay.
skills, other like
Deal.
upskilling, other certifications that are needed in doing that. Yeah. But yeah, I think that's actually most of everything. And academia teaching, sorry, how can I not say this? I have actually lectured
Yeah.
part-time as well.
You have.
Um, Actually, towards the end of last year, I was lecturing second years, helping
Okay.
them prepare for, yeah, helping them prepare for. So, fortunately for our department, if you don't do so well in the exam, you have a chance to write a supplementary exam. So basically, it was like a crash course over a couple of weeks, I think, where we're just going over all the material, learning material, and then you write the final exam again. So basically, I
Okay.
was a part of that as well. So teaching is also something, because once you have obtained the degree, you can also transfer that knowledge to other people, students who were like, you've been in their place, you've been there, you understand
Yeah.
how maybe some of the concepts were difficult to understand from lectures, because when you see a lecture you're like, oh, okay, this is an expert in their field, but then me, I'm just, I'm just here, I'm just like, I can just and because I've been there, I understand sometimes that whole being able to be relatable to other students, especially being a Black woman in South
Yeah.
Africa, also something that maybe sometimes it's hard to ask the lecturer, oh, but I didn't get this. But then I've noticed that a lot of students are actually more willing to ask us, like postgrad students, because we also help with tutoring as well. So besides part-time lecturing, we can also help tutoring and help undergrad students, maybe with concepts that they don't understand, or if it's a tutorial, if there's questions where they're like, this doesn't make sense, they come to us. And that's
Okay.
also a way that I also find I really like helping people. So if that takes you any step closer to your degree, then I'm really there to help. And yeah, that's another area that can be explored, just depending on you as a person if you'd want that. But
Yeah.
academia teaching is something that I really do also. Yeah, I also really like.
Okay.
Yeah, that's, I think I've covered
Did
most
you
things.
mention did you mention research? Oh, you mentioned research because that's where you work.
I did, yes, research and development,
Yeah,
yes. It's
yeah.
just that I'm more in the biospace, but you can do R&D for almost any company, just depending on if they have that in their work portfolio. Or yeah, but R&D is definitely. But I also think it's easier for me because I've been in research, like after having done my master's. So there's
Yeah.
also that. Yeah.
Is that
Yeah.
why you did your master's? Is it because you wanted to go into research?
I was lost. I didn't know what I wanted. I didn't know what I wanted. I really, you know I think you said this earlier on, but I got to final year of my undergrad and I had absolutely no idea where I was going next.
Oh Lord.
Nothing. Nothing. There was absolutely nothing. I just wanted to get the degree because towards the end, yeah, it was getting a bit difficult. But Fortunately, so what they do, or basically the degree that I did, it's an honors degree. So in your last year, you have the final design as well as a mini thesis that we had to do. So that was more of partnered work where you're in a pair, and so there are a couple, I think maybe 7 research groups in our department. So basically different supervisors or academics, they have parts of maybe their research that they give to undergrads to perform, like if it's experimental work or if it's computational work, they give you, so it's basically a part of their research that they want you to do, and you have to basically do whatever the, I did experimental work, whatever the work is, get your results, and then create a report, like a proper intro, methodology, all of that, and write a report and then present on that. But based on like actual research that's being done within the department. So in doing that, I was placed in the bioprocessing research group. And it was only then, like the exposure to, besides the actual work, which I find fascinating, but the work environment, I really enjoyed the people that were there and the nature of the work as well, because it's kind of interesting working with living organisms as opposed to just like maybe, I don't know, but yeah, I really just like working with living organisms. And so that's your bacteria or your enzymes that I was talking about. So after having been exposed to that for 6 weeks is when I was like, you know what? I started asking around. I started just talking to people and finding out, oh, okay, you're drinking this. How do you like it? How's this? How's that? And then from doing that was when I then approached the director, who actually ended up being my supervisor.
Yeah.
And I just asked him, okay, what projects do you have for next year? This. And from there is when I actually started. I was like, okay, masters, let's do a master's degree. Because I became, you actually are right, I became interested in the work that you're doing, the research work that they were doing. And then so from there, it's just been research. Yeah.
Okay. All right. Okay, that's good to know. The reason why I asked you that is that's something that I've been asking because I was looking forward to doing also shedding light on that area, because mostly after school people don't know the right reasons to do a master's. I mean, you can go into it and then you be disappointed because the reason why you did it is not, it did not work out at the end. So I just wanted to also give information on that and shed a light on that area. And I'm going to involve you in that when I do it. Oh my God, we need to do lots of things. That's the third thing we need to do after this conversation. Yeah, the third. Yeah, so what I wanted to ask you was concerning consulting. You said that there is the option of working for consulting. So, when you say consulting, for me as a civil engineer, in my head, I'm thinking, because for civil engineering, consulting firm is, I can start a consulting firm as an individual, as Marion. I can, when I meet all the qualifications by the regulator, I can go open up consulting firms, and then when there are bids, I go bid if they want to build a building somewhere or a road, then I can bid and get the work and do it. Is it the same way for chemical engineers? And then what I wanted to ask is, what kind of projects do you do in these consulting firms? Because I'm thinking of, if it's, for me, it's easy. The government will go say, we want to build a road from here to here. And then as we go and say we are interested, we have the qualifications and the people and the capabilities. So what kind of projects do you do in chemical engineering?
As a consultant, thank you for your question. I can speak to a friend of mine. Yes, actually, she works for a minerals related kind of consulting firm. So what they do in that space, so I didn't talk about mining. I'm sorry, I didn't mention mining. You can go into
There is,
mining as well. Mining and
okay.
metallurgy is another field, sorry, that you can also go
So
into as
how
a
would
chemical
mining come
engineer.
about?
Sorry, come again?
How what you'd be doing in mining? I know
Oh, in
I'm
mining. Okay.
picturing mining
So
and
in
I'm seeing big
that's
machines
right.
and they're digging things underground. So where's the chemical engineer coming in?
So what okay, so a chemical engineer, what we can do actually, it's called the branch of it is called metallurgy. So basically,
Mhm,
when you get after the rock or whatever it is has been mined, because remember, it doesn't come out just as gold, like I have gold here. No, it comes out in embedded in like rocks or other different materials, right? And you at the end of
mhm,
the day want your final product, which is maybe your gold or your diamond or whatever it is that
mhm.
you're mining. So what we do
Okay.
as chemical engineers, because yes, there's a research group actually that specializes in minerals and
Mhm,
metallurgy. What they do is that they take that ore and then by a method, I think there are different types of methods, but the one that I know of is called flotation. So basically
okay.
it's a chemical kind of environment where why are you looking like that? It's a chemical sort of environment where
Mhm.
where
Sorry.
you flotation. I please chemical engineers that are listening to this. I don't I This is just based off the top of my head what my friend would tell me. But like basically you'd float what is floating? You'd submerge it into a certain kind of chemical such that those other unwanted, like the debris, the other particles, they get separated out. And then from there, you get your final grade of ore or mineral or whatever it is that you want. And then from there, there's a department for metallurgy, which actually, because it might not just be gold, it might be gold with a little bit of something in it, or it might be copper with iron. So there's another section that actually looks at what the chemical properties of the grade of that ore, what it is. So it basically
Mhm.
tells you, okay, how much of this is actually copper, how much of this is actually platinum, how much is, yeah. So, which is also a little bit of analytical chemistry. I can see a little bit of chemistry coming into just analyzing that material, but then the chemical engineer would have separated out that whatever ore or whatever it is from the big rock or the sand or whatever it is. Yeah. So what my friend does, she works for a consulting company where different mines, they have contracts with different mines where they send in like a sample from their mine, a sample from wherever it is from, yeah, they send in a sample and then they want it analyzed for them. They
Okay.
want to know, okay, what is the grade? So basically what I've described is what a consulting firm for metallurgy would do for in the mining space. So basically, they say, okay, this is what we have. We want to know this and this. Can we use these? So what happens is for different minerals or materials, you need different chemicals in order for you to actually get your final product, the final purified product. You can't just use
Mhm.
different things and expect for the best because the different sand types, they're different. There's a lot of things that you need to take into consideration, which the chemical engineer or metallurgist or mineralogist knows. They know that. So they might come and say, okay, we've been using this X, Y, and Z for us to purify this. We want to see if we use a cheaper chemical compound, what would that mean? Like, is it possible? Does it affect the grade? Something like that. And then you then have to do a sort of analysis on that and see, okay,
Mhm.
they've
Yeah.
done this. What if we change this? What happens? And
Yeah.
then you write down your report findings and then send it back. Yeah.
Yeah. Problem solving right there.
Yes. Yes.
It's
Yes.
all engineering is all about. Okay.
Literally. Yeah.
Yeah. So
Type of
generally for chemical engineering, yeah, what type of projects do you do? I think you
where
mentioned
we are
some
the
of them. I
lead.
think
I'm trying to think of something that could be done maybe in the food and beverage industry where uh I always like having examples that are based off real life experiences. Um,
Yeah, yeah.
but I think I've already like talked about most of the things that
All of them.
I am aware of. Uh,
Okay. Can I ask something while you think about it? Because I'm just
okay, sure,
thinking
yeah.
right now, is it that chemical engineering is more uh, operations than projects? You see, there is project and operations. So, or is it both?
Mm,
So, I give an example.
mm,
If we are, if we are designing a nuclear power plant, that's a project. But then if we are running it and you were talking about the equipment and the water and the temperature,
oh,
so I'm guessing that
yeah.
will come in. So is it, or do you do both? Do you do both the project and the operational part of it?
That's a very good question. That's a very good question. And to answer you, I think it's case dependent, but it can be both. It can be both because you could be a process engineer working on a plant, fine. Maybe you're producing whatever you're producing. But then, yes, you are ensuring that the process flows smoothly, you're checking everything, but then it may come up similar to how I was talking about the consulting job where the company decides, hey, actually, I feel like we're using too much utilities, or maybe we're using too much of a heating medium or we're using too much water to cool the system.
Yeah,
Isn't there
yeah.
perchance a way where we can reduce our energy consumption? What kind of way can we integrate the heat that is already in our process instead of
Mhm,
um what you call it, procuring more cooling water or whatever cooling
mhm,
medium you have? In that case, it
mhm.
would be a project, but then you are still someone who is actively working on the plant, but you could be called in to handle that as a project. Yeah, I think
Mm.
it's case dependent. It's case dependent.
Okay.
So it's either they would ask you to do it or they would then
Mm.
outsource. They would then
Okay.
outsource. Yeah. But it just,
Okay.
yeah, thank you. That's a very good question. That's a very, very good question. And I hadn't thought about it like that. Operations or projects, both,
Yeah,
both,
yeah. Both of
both.
them, so they would work in both.
Mm,
All right. All right.
definitely. Yeah. That's a very good,
Okay.
that's
So,
very insightful. Yeah.
all right. All right.
Mm-hmm. I can think of one particular colleague of mine. Okay, I'm seeing. Hi, Jackson. So I have a colleague of mine. His undergrad was in mechanical engineering, if I'm not mistaken, but he did his master's in chemical engineering. So what they needed was a cross between. So what I was talking about, how we can design a piece of equipment, right? But then it's the mechanical engineer who needs to make sure that it actually works. So he worked with
Mm-hmm.
chemical engineers. And so it was in this research group which deals with ice. So think of the Antarctic. Think of so I'm not too sure of the chemistry or the geo, or I don't want to lie. But basically, as ice melts, or as it forms rather, there's a different, there's a, how do I say it? It has certain properties that it has, and you can use the properties from that over years to predict the future, not the future, but the future of ice sheets, because you know how they're melting, and then what global warming and blah blah blah. So what
Mm-hmm.
he did was that he worked with a chemical engineer in order to create a certain device. I'm just not sure what the device actually was and what it did, but that equipment they needed to use it to analyze ice samples. So literally, they traveled to the Arctic or the Antarctic, extracted ice, and then he had to use the equipment that he had designed. So he designed it with a chemical engineer such that they could use it for analysis. I'm saying things very high level because I'm not really sure of the correct terminology. I'm not sure. But
Okay.
that is an example of a collaboration that was done across mechanical and chemical engineering departments, which I found really, I was like, oh wow, I thought you're mechanical. Why are you in chemical engineering? But yes,
Yeah. Okay.
yeah. So that just goes to show a practical example of how chemical engineers can work hand in hand, or definitely we work hand in hand with mechanical engineers, because by myself or as a chemical engineer, I wouldn't have been able to actually create whatever it is that it actually works. I've seen videos of he finished recently. I've seen videos of the equipment that he created, designed, tested.
Yeah.
It works. Yeah. But I'm so sorry. I'm speaking high level. I'm not really sure of the intricacies of mechanical. I'm so sorry, Jackson. But we do work all together, as I think we mentioned earlier on with Marion, that engineering, we're all interlinked somehow, some
Yeah.
way, always. Yeah.
Yeah. Sure.
Yeah. It's supposed to be a 2-year degree. I've
Wow.
gone through 2 years and I have nothing. Eventually, in the third year, so 2022, was when finally, after another expert they were with me in the lab, they saw me do everything, and that's when the other experts said, this is not working, was when we decided to change direction and use another source.